Hey there, welcome to Everything Yagnik. My name is Yagnik and in this video I am going to explain inverse hyperbolic functions. Without wasting any more time, let's get started. Inverse hyperbolic functions. Let's get the introduction of inverse hyperbolic functions. The hyperbolic sine function is a one-to-one function and thus has an inverse. The inverse function of hyperbolic functions is known as inverse hyperbolic functions. It is also known as area hyperbolic functions. The inverse hyperbolic function provides the hyperbolic angles corresponding to the given value of hyperbolic function. The inverse hyperbolic functions are inverse hyperbolic sine function, that is sine h inverse, also denoted as arc sine h or arc sine h. Inverse hyperbolic cosine function, that is cos h inverse. Inverse hyperbolic tangent, tan h inverse. Inverse hyperbolic cosecant, cosec h inverse. Inverse hyperbolic secant, sec h inverse. Inverse hyperbolic cotangent, cot h inverse. Inverse hyperbolic sine function. Let's talk about that first. If the domain is the whole real line, then the following formula is for inverse sine h. Inverse sine h, that is sine h inverse of x, is defined as ln of x plus in square root x square plus 1. If we draw the graph of y is equals to sine h inverse x, then we get something like this. There is a curve in first and third quadrant. Now let's talk about inverse hyperbolic cosine function. If the domain is closed interval 1 to infinity, the inverse hyperbolic cosine function, that is cos h inverse of x, is defined as ln of x plus in square root x square minus 1. If we talk about the graph of y is equals to cos h inverse x, we have to ignore the imaginary parts of complex x and y arguments. So the graph looks like this. Now let's talk about inverse hyperbolic tangent function. If the domain is the open interval -1 to 1, then inverse hyperbolic tangent function tan h inverse x is defined as 1 by 2 ln 1 plus x upon 1 minus x. We have the graph of y is equals to tan h inverse x like this. Here also we have to ignore imaginary parts of complex x and y arguments. Now let's talk about some other hyperbolic functions. Inverse hyperbolic cotangent. If the domain is the union of the open intervals negative infinity to negative 1 and 1 to positive infinity, then the cotangent function, that means inverse hyperbolic cotangent function, is defined as 1 by 2 ln x plus 1 upon x minus 1. Inverse hyperbolic cosecant. If the domain is the real line with 0 removed, then the cosec h inverse of x is defined as ln of 1 by x plus square root of 1 upon x square plus 1. Inverse hyperbolic secant. If the domain is the semi-open interval 0, 1, then sec h inverse of x is defined as ln of 1 upon x plus square root of 1 upon x square minus 1. That's it for this video. Like and share this video. Subscribe to Everything Yagnik for more upcoming mathematics videos. Thank you for watching this video.